We're going to simplify these two expressions and we need to do multiply the coefficient first. So we have 3 and 5. So we multiply 3 and 5 first. So 3 times by 5. And I'm going to put 8 to the 7th power, 8 to the 2nd power after that. So 15, 8 to the what power? When we multiply the numbers, like when we multiply exponents, so add we add the exponents, right? Because we multiply a how many times? 7 times. And we multiply 2 how many times? Twice. So a to the 7th, a to the 2nd, and a to the 2nd power, a and a. If I multiply these two, then how many times you actually multiply a in total? A in total, a to the what power? 7 plus 2, a to the 9th power. So it's going to be 9th power. The next one, same thing, 2, 9. So it's going to be 18, a to the negative 7, and a to the 7. So use this strategy. We're going to add them together, add exponents. So it's going to be a to the negative 7 plus 7. So it's going to be 18, a to the what power? 0 power. Anything to the 0 power? 1. So it's going to be, the answer is 18 because this part is 1. Today we're going to talk about exponential function. So exponential function. So exponential function is a function of the form y is equal to a times a is coefficient and b to the x power. So if you have exponents and if you have x in the exponents spot, then you can think that, oh, this is exponential function and x should be a real number. So for example, like y is equal to 2x, y is equal to 1/2 to the x power. So an exponential looks like this. It's slow. It increases really slowly, but at some point it's like increasing, like it just spike, like it's increasing really fast. Or it was like decreasing really fast, but it's going to be decreasing slowly. So in this lesson, I really want you to be familiar with this exponential function. Just remember the form and how it looks like. All right, so far, and we've been talking about many different types of functions. So the first one is, we know this linear function. So it's increasing, y's are increasing in a constant rate, and it's a straight line. And this function, I think you will learn in Algebra 2. It is called absolute function. Absolute function. And this kind of like symmetric and decreasing, but at some point, if it's increasing, this bell shape function is quadratic function. Quadratic function. And then the last one, we just learned this exponential function. Exponential function. All right, so now let's try to graph the exponential function and find the range of the function. All right, so I know you guys have a table on your paper, and input is going to be, like we have 5 numbers here, and input is going to be in the exponents. So when you plug in -1 to x, it's going to be 2 to the negative first power, and we know how to flip it. This negative means 1 over. It doesn't mean that you have to put negative in front of it. No. So 1 over, and then you put the leftover 2 to the first power, 1 over 2. So f of x is going to be 1 over 2, which means you can get to this coordinate. So negative, when you plug in -1, then the output is going to be 1/2. So I'm going to have -1 here, 0, 1, 2, and 3. So let's go up by 1. 1, 2, 3. So 1/2 is going to be like here, right? So this is -1 and 1/2. So when you plug in 0, 2 to the 0 power. So what is anything to the 0 power? 1. So when you plug in 0, the output is 1. So 0, 1. When you plug in 1, 2 to the first power, 2. So 1, 2. 1 and 2. So now you see the values are increasing. When you plug in 2, 2 to the second power, 4. And 2 and 4. 2 and 4. What if you plug in 3, 2 to the third power, 8. So when you plug in 3, the output is 8. 3 and 4, 5, 6, 7, 8. 8 is here. So it's like this. So you see that, oh, it's increasing slowly, but at some point it's like spikes here, right? So it's increasing really fast. So let me just connect the dots. So it's not gonna be a straight line. So it's gonna be a curve. So let me do that. All right, as you see, the y values are increasing, but it's really like slowly increasing in the beginning. And this one, it's not going to be a negative number, so it's always positive number. The exponent itself, it doesn't have negative sign, so it should be all the positive number. So it's increasing, but it's really increasing fast as time goes by. So what's the range? So range, what is the set of y values? So the range of this function is going to be all the, hold on a second, let me change the color. Okay, all the positive number, those are all the range, right? And until 0, until it gets to 0, it's not going to be a 0, like I mentioned. So the range, we already know that, learn about the notation. So I'm gonna put, okay, 0 is not included, but it's going to be including all the positive number until the infinity, okay, positive infinity. So 0 to infinity, but 0 is not included. All right, the next one, we just have different function, but like the strategy we have, it's the same strategy. So now I'm gonna plug in -2 to exponents. So 3 to the -2nd, 3 to the -1st, 3 to the 0, 3 to the first, 3 to the second power. So now I'm gonna put -2, -1, 0, 1, 2. So now we have 5 inputs, and what's going to be the output? So let me just go from the bottom. 9 plus 1, 10. 3 plus 1, 4. And this guy is anything to the 0 power, 1, not 0. So it should be 2. And this is going to be 1/3 plus 1. So it is 4 over 3. And this is going to be 1/9 plus 1, so 10 over 9. So it is like 1 and 1/9 and 1 and 1/3 and 2, 4, 10. So let me plot this. I just have 5 points on the graph, and if you connect this, and you will get this curve. The curve looks like this, and let's find the range. So the minimum value of this guy, it was 0. So the range is 1, 2,